Hello, welcome to this video. In this video, we'll look at quadratic equation chapter. We'll look at the key concepts of quadratic equation and we'll look at the common questions that come in the exam. Shall we start? Let's go. First, we will look at what is a quadratic equation. A quadratic equation, especially the standard form, is an equation like ax squared plus bx plus c equals 0, where x is the variable in the sense it's the unknown. We don't know the value of x. We want to find the value of x. A, B, C are constants. It is shown in blue here. Those are constants. In other words, we know the value of them. They are also real numbers. And only condition about the constants is that A should not be 0. Okay? So this is the standard form of quadratic equation. Let's look at a couple of examples. So in this example, we have x squared plus 2x plus 4 equals 0. Now, you may think that there is no a in this case, but actually there is a. It's just that it's assumed. You can think of a as being 1. So in this case, a is 1, b is 2, and c is 4. All of them are real numbers. A is not 0 and the variable is x. So this is a quadratic equation. Now let's look at the second equation. Now this is an interesting equation. I've chosen specifically to show some key points. The first point is the variable does not have to be x. It can be y, it can be z. As long as the variable is unknown, it does not matter. The second thing that this equation is interesting is the coefficients are not just integers. So in this case, the coefficient is a rational number like root 5. In this case, the coefficient is a fraction like 8 by 15. In this case, the coefficient is a negative number. So it can be a negative number, it can be irrational, it can be a fraction. As long as it's a real number, A, B, C's can be anything. It doesn't matter. Okay, so this is another example of a quadratic equation. Let's look at an examples of equations which are not quadratic and why. These are not quadratic equations and let us see why. The first one is not a quadratic equation because it has two different variables. Okay, it has x and y. So there are two different variables. The highest power is 2. So it is like a quadratic equation, but it's not because there are two different variables. A quadratic equation can have only one. This is not a quadratic equation, the second one, because the highest power is 3. So the highest exponent power of y is 3. In a quadratic equation, it can only be a 2. So the maximum allowed in this case is only y squared, but we have y cube here. Hence, it's not a quadratic equation. This is a cubic equation. The third one, 8y minus 9, is also not a quadratic equation because you can think of a y squared term where a is 0 in this case. Right? The highest power is 1. Hence, it's a linear equation. It's not a quadratic equation. Alright, shall we go further? Let's go. Now, there is a concept called root of a quadratic equation. Now, this is an important thing to understand. Given a quadratic equation, what is a root? A root of a quadratic equation is a real number. In this case, we are talking about alpha, Greek letter alpha. A real number alpha is said to be a root of quadratic equation ax squared plus bx plus c equals 0 if a alpha squared plus b alpha plus c happens to be 0. So instead of x, if you replace alpha and it ends up satisfying the equation, then it is said to be a root. Let's look at a couple of examples. Let's take this quadratic equation x squared minus 4x plus 4 equals 0. We can see that 2 is a root of this equation because if you substitute for the value of 2 instead of x, you get 2 squared, which is 4, minus 4 times 2, which is 8. So 4 minus 8 plus 4. So if you add all of them, you get a 0. Now because of that, we can say 2 is a root. Similarly, we can say that 1 is not a root of the same equation 1 is not a root of a same equation, because if you substitute the value for 1, you get 1 square minus 4 plus 4. Minus 4 plus 4 cancels, you're left with 1, and that is not equal to 0. So 1 is not a root and 2 is a root. So 2 was a root because the equation was satisfied. 1 is a root because the equation does not satisfy for the value 1. So that's the concept of root of an equation. Now let's look at the nature of the roots. This is a common question that gets asked in the examination. We need to understand what is the meaning of nature of the roots. Now the nature of the roots means two things, which is how many roots do you have and what kind of roots are they. Let's look at them. Now the nature of the roots depends on something called discriminant. This is a new term, discriminant. What is discriminant of a quadratic equation? A discriminant of a quadratic equation is b square minus 4ac term. b square minus 4ac term is the discriminant of a quadratic equation. Now, depending on the discriminant value of a quadratic equation, we can have three different scenarios. The first scenario is if the discriminant value is greater than 0. If the value of the discriminant is greater than 0, then we'll have two roots. Both will be distinct and both will be real. So we'll have two real roots and both will be distinct. Distinct means they will be different numbers. If it is equal to 0, we still say it has two roots and they are equal to each other. Okay? We still say that there are two roots and both of them will be equal to each other. If it is less than 0, we say that there are no real roots. There's a complex root, but that is a topic for a future video. As far as this video is concerned, we can say that if discriminant is negative, then there are no real roots. Now this is quite an important concept, discriminant and nature of the roots. And let's look at by an example. Okay, let's look at this first equation, x squared plus 3x plus c. The discriminant happens to be 3 square, which is a b square term, 4ac, which is all 1. So we have 3 square, which is 9, 9 minus 4, which is 5. Now because it's positive, we have two distinct real roots. The second equation is x squared plus 2x plus 1 equals 0, where x happens to be, b is 2, so in other words 2 squared minus 4, which is 0, hence we have two equal real roots. Third one, instead of 2x we have x, and b squared will be 1, 1 minus 4 is minus 3. We say that in this equation the answer is there are no real roots, because discriminant is negative, there are no real roots. Let's see how to solve a quadratic equation. Okay, the whole objective of quadratic equation is we want to find the roots. That's the usual problem of having a quadratic equation. We want to find the value of x if it's ax squared plus bx plus c equals 0. There are three ways to solve a quadratic equation. One is a factorization method, second is a completing the square method, and third one is using quadratic formula. Let's look at each of them briefly. Let's look at a factorization method. What's a factorization method? A factorization method is you have an equation like this, x squared plus 5x plus 6 equals 0. We convert it into this form like x plus a plus x plus b equals 0. And then we equate each of them to 0. So in this case, x plus 3 we equate to 0, x plus 2 we equate to 0. And once we equate this to 0, we can say that x is either minus 3 or it's minus 2. Okay. So we take an equation like this, factorize into x plus 3, x plus 2 equals 0, then equate each of those terms to 0 and show that the roots are minus 3 and minus 2. Now, when you factorize, you might get an equal root situation. So if you take x squared plus 2x plus 1 equals 0, that is like x plus 1 whole square. In other words, x plus 1 equals 0. So you have two roots. Both of them are equal and they are equal to minus 1. All right. Now, you may also have to factorize an equation where the term a is not 1. In other words, you have 2x squared plus 3x plus 1. In this case, if you factorize, you'll get a term like this, 2x plus 1, x plus 1 equals 0. And there you have 2x plus 1. When you equate it to 0, x will be minus half. So x is a fraction. Whereas the other term, when you equate, you can show that x equals minus 1. So there are many videos in this channel where we talk about factorization, especially the questions that came in the exam. Second method is completing the square method. This is unlikely to appear in the examination, but this is the method that was used to find the quadratic formula. Let's look at what this method is. Let's take this example. Consider the following quadratic equation. So we have a quadratic equation called x squared plus 10x plus 28 equals 0. Now this quadratic equation is not a perfect square. Why? Because 25 is not a square of 5. Now if 25 was a square of 5, we could have done x plus 5 whole square. In other words, because even you expand this, you get x squared plus 10x plus 25. Here we have 28. We don't have 25. What do? You split this into two parts. It is possible to write the original quadratic as a sum of a square and a constant. So you split it into two parts, 28 into 25 and 3. So you end up having x plus 5 square equals 3 equals 0. So you may ask, okay, what do you do after this, right? This is called completing the square, but what do you do after this? So what you do after this is you move 3 to the RHS, it becomes negative minus 3. You take square root, and once you take a square root, you can find the value of x. This is the method that is actually used to find the quadratic formula equation itself. Let's look at a proper problem and see how this is solved. So take this example. X squared plus 6x plus 5 equals 0. The first step is to complete the square. So in this case, the completing the square method would mean that we have to remove minus 4. So you have to add minus 4. And then you'll get x plus 3 whole square. Now why? Because 3 squared is 9. 9 minus 4 is 5. And if you take this and expand, you get 6x. Okay. Then we solve the term. How? By moving the minus 4 to the other side. So I have x plus 3 square equals 4. Then you take a square root. So when you take a square root, it is plus or minus 2. If it is minus 2, x becomes minus 5. If it is plus 2, x becomes minus 1. So this is how you solve it. There are many questions in the textbook where completing the square method is shown, but in examinations, this question is usually not asked. However, there is a chance they may ask. Okay. Now, let's look at the third one, which is the most widely used. What's a quadratic formula? So using the completing the square method, we can show that roots of a quadratic equation can be written as minus b plus or minus square root of b square minus 4ac divided by 2a. So there is plus or minus in the means that one root is minus b plus this term. Another one is minus b minus this term. So this is only true if b square minus 4ac is greater than 0. If you remember, this is discriminant, and the nature of the roots you can see is based on discriminant here. So if discriminant is positive, then we'll have a square root, and hence we have real roots. If discriminant is negative, then square root of negative is not real. It's a complex number, and that is how we get it. So this is commonly used to solve quadratic problems. All right, so let's look at the exam questions. What are the common questions and how do you solve them? First, let's look at 1-mark question, okay? So the common 1-mark question is they will ask, write the standard form of a quadratic equation. This is quite a common question. It came in the model paper of 2021. What's the standard form? Standard form is ax squared plus bx plus c equals 0. So that's the standard form. So that's the question. That is usually a 1-mark question. Another kind of question is they might ask something as simple as this. What you're supposed to do is you need to convert this into ax squared plus bx plus c equals 0 form. This came in 2020 main examination. A third kind of question is they might say that the roots of the equation are equal. Then you find the value of k. Now, how do you find this? You find the value of determinant and equate it to 0, because we know that if the determinant is 0, then the roots are equal. So once you find the value of determinant, you can find the value of k. The fourth kind of question they might ask is, if one of the roots is -4, what is the other roots? I mean, this is already factorized. They've said that, okay, if you equate this term, it is -4. Then if you equate the second term, you get this other root. So in this case, the answer is -3. These are the usual 1-mark questions from the last year and the model paper. Let's look at 2-mark questions. What kind of questions do you get? The most common 2-mark question is find the value of the discriminant and tell the nature of the roots. So you can see that in model paper 1, 2, supplementary and main exam, you literally have exactly the same kind of question. Find the discriminant of a quadratic equation. Equation is given and you're supposed to find the nature of the roots. Right? So this is almost a certain question that you get in the examination. You may get a slight twist question. So in this case, they have said, prove that a quadratic equation has distinct real roots. Now, again, what you're supposed to do is find the discriminant value and say that the discriminant can never be negative. Hence, it is having distinct real roots. Right? So that is an interesting question, but usually you get just a simple find discriminant and write the nature of the roots. There are videos in this channel which cover these questions and tell you the distribution of marks for each of the steps. Do have a look. The third kind of question you get rarely is you solve by factorization. You may not get this directly, but this is part of like a 3-mark question, but they do ask sometimes that solve by factorization. So you get a question like this and you're supposed to solve it by factorization. The other way of asking the question is, how do you solve using quadratic formula? So this is again a 2-mark question where you're supposed to find ABC values and use the quadratic formula and find the answer. Okay, so it was there in both the model papers. Now finally, let's look at a 3-mark question. A 3-mark question is usually a statement question. So they give you a statement. You're supposed to form a quadratic equation and then solve it. So let's look at some of the questions. So I've looked at last 2 years and there are 3 kinds of category. The first one is speed related. What does that mean? Take this example. A train travels 480 kilometers at a uniform speed. If the speed had been 10 kilometers more, it would have taken 4 hours less. Find the speed of the train. So you have to form an equation and solve it. We'll see what kind of equation to form. Similarly, there's another question which is to do with bicycle and time taken by 2 people to reach the office. Okay. Again, there are separate videos covering these 2 questions. Take a look. Let's look at the speed question a little bit for you to get an idea of how to solve this. So the speed question, what you do is we use the concept called time taken equals distance divided by speed. You form this equation, something like this. And then eventually you simplify this equation, you end up getting a quadratic equation like x squared plus 10x minus 1200. You factorize and you show that the speed is 30 kilometers per hour. So in other words, you take a text statement equation, convert it into quadratic equation, and then you find the speed. Okay. The other kind of questions you might get is area question. Now, area is a typical problem where you'll end up having a quadratic equation. If you only know the perimeter and the area, in this case, the perimeter and the area of a rectangular playground is given, find the length and the breadth. So you will have a quadratic equation where you'll know one of them, like a length, and then you have to substitute in the other and find the value. So that's the area question. Again, there are videos, you can take a look. It doesn't have to be rectangle, it can even be triangle. And in the case of triangle, they given a relationship between altitude and the base, and then they've asked you what is it to find them given the area. Okay. So it can even be diagonal. In this case, they've given a diagonal of a playground and the relationship between diagonal and the smaller side, and then you're supposed to find the sides of the playground. Let's look at one of the examples to see how to solve this. So I'm looking at the perimeter and area of a rectangular playground problem. So basically what have they given? So they have said that the sides, the perimeter is 80 meter and area is 384 meters square, and we are supposed to find the length and the breadth. So you can see its perimeter is 2x plus y equals 80 meters and xy equals 384 meters square. Now, after you follow these steps, which are there in another video, you can watch it, you end up getting a quadratic equation like this. And then you solve via factorization and you can show that the sides are 16 and 24. Okay. So these are quite detailed and involved steps. There is a video covering all of this end to end. Do have a look. Final one is numerical kind of question. So where they give you like sum of two natural numbers is 9 and sum of their reciprocals is 9 by 20. Find the numbers, right? Or two consecutive odd integers. The sum of those squares are 290. Find them. So these kind of question. And how do you do it? Again, similar concept. You end up representing the two numbers as x and y. Do a lot of steps. Finally, you get a quadratic equation like this. X squared minus 9x plus 20 equals 0. And you equate it by factorization to 0 and you get the value. Again, there's a separate video covering this particular problem. Take a look at that. I've shown here so that you get a feel for how to solve this problem. Okay, so that covers the 3-mark question. So we have looked at concepts of quadratic equation, all the key concepts of quadratic equation. And we looked at 1-mark, 2-mark and 3-mark questions that have come in recent exam and the model paper. Hopefully this video was useful to you. Thanks for watching this video. We'll come back to you with a new video soon. Bye.